For over half a century, space travel has been expensive, dangerous, and reliant on powerful rockets that burn massive amounts of fuel just to escape Earth's gravity. But what if there was another way? A way to reach space not with rockets, but with an elevator, one that stretches from Earth's surface to the stars. This is the vision of the space elevator, a revolutionary concept that could make space travel as cheap and routine as boarding an airplane. In this video, we'll explore the history, the technology, the challenges, and the future of this mind-blowing idea. Could space elevators be the key to colonizing the moon, Mars, and beyond? Let's find out. A space elevator is exactly what it sounds like. A giant tower or cable that extends from Earth's surface to geostationary orbit, a point 35,786 kilometers above sea level, where an object orbits the Earth at the same speed the planet rotates. At the top of this cable would be a counterweight, perhaps a space station or even an asteroid keeping the structure balanced. Elevator cars, powered by electric motors, laser energy, or even solar power, would climb the cable, transporting people and cargo into space at a fraction of the cost of rocket launches. This idea isn't just science fiction, it's based on real physics. And if we can overcome the challenges, it could transform our future. The idea of a space elevator dates back over a century, 1895. Russian scientist Konstantin Tsiolkovsky, one of the fathers of modern rocketry, imagined a tower reaching into space, inspired by the Eiffel Tower, 1960. Russian engineer Yuri Artsutinov expanded on the idea, proposing a cable system from Earth to geostationary orbit, 1979. Arthur C. Clarke's science fiction novel, The Fountains of Paradise, popularized the concept, inspiring a new generation of scientists. 2000s to today, NASA, Japanese researchers, and private companies have seriously studied the feasibility of space elevators. But why build one? What makes it so revolutionary? Right now, the biggest problem with space travel is cost. Sending just 1 kilogram into space with rockets costs between 30 and 50. Even with reusable rockets like SpaceX's Starship, it's still expensive and limited by fuel. With a space elevator, costs could drop to just 100 per kilogram or even less. It would be safer, as there's no risk of explosions like with rockets. It would be environmentally friendly, with zero emissions from rocket fuel. It would enable daily space travel, like taking a train or plane. Imagine colonizing the moon and Mars with a cheap, reliable way to send cargo and people into orbit. A space economy could emerge, with hotels, research stations, and industries in space. But how do we actually build it? Building a 0 kilometers cable is no small task. The biggest challenge is finding a material strong enough to handle the immense tension and weight. Possible materials for the cable: carbon nanotubes, 100 times stronger than steel, but still difficult to produce in long strands. Graphene, ultralight and super strong, but production is still a challenge. Diamond nanothreads, a theoretical material that could be perfect but is still in the research phase. The cable must also resist space debris, radiation, and extreme weather, while being light enough not to collapse under its own weight. Powering the elevator cars. Instead of fuel, the cars could use solar power, magnetic levitation, or laser energy to move up and down the cable. A floating ocean platform near the equator would be ideal, reducing the risk of storms and earthquakes. Even if we perfect the materials, there are serious challenges. Space debris and meteoroids. Small objects traveling at high speeds could damage the cable. Political and security risks. If one nation controls it, could it become a strategic weapon? High costs and engineering hurdles. The initial cost could be trillions of dollars. gravity, and tidal forces. Earth's movement could put stress on the structure. Despite these problems, experts believe we could see a working space elevator by 2050. While a space elevator on Earth is still decades away, there are easier alternatives. Lunar space elevator. A shorter cable could stretch from the moon to a satellite, making moon missions cheaper. Mars space elevator. With lower gravity than Earth, a Mars elevator would be easier to build and could support colonization. Skyhooks and rotating tethers. Shorter structures that catch rockets and sling them into orbit. A working space elevator could change everything. Tourism. Imagine space hotels and cruises, available for the price of a plane ticket. Colonization. Permanent bases on the moon, Mars, and beyond. Resource extraction. Mining asteroids for rare metals could power the next industrial revolution. Interstellar travel. The first step toward expanding beyond the solar system. In the next few decades, we may see the first prototype take shape. One day, space elevators could make science fiction a reality, bringing humanity closer to the stars than ever before. The dream of a space elevator is bold, ambitious, and full of challenges. But the greatest achievements in human history always begin as impossible dreams. The future of space travel is not just about rockets. It's about innovation, engineering, and daring to believe in the extraordinary. Would you ride a space elevator? Let us know in the comments. Subscribe for thrilling science clips.